Okay, so due to Snowvid 21, we have not done algebra in quite some time, but whenever we last did algebra, we were solving quadratics by factoring, and we're going to continue doing that, but we're going to do a special kind of factoring called completing the square. Now, when I say square, I don't mean the shape, like 4 sides, 4 right angles. I don't mean that kind of square. I mean a polynomial that when you factor it can be written as the product of 2 identical binomials or a binomial squared. So let me give you an example of what a perfect square looks like. X squared plus 8x plus 16 is an example of a perfect square trinomial. And the reason this is a perfect square trinomial is because if I were to factor this, it would factor into x plus 4 times x plus 4, which can be written as x plus 4 squared. Why is writing something as x plus 4 squared a good thing? Well, because now we can use the square root property, which is to take the square root of x plus 4 squared. So that's one of the reasons that we like perfect square trinomials. So what do you do if you don't have a perfect square trinomial, but you really, really want one? What if I really, really want a perfect square trinomial? Is there a way that I could do that? And the answer is yes. There's a way that I can take something that is not a perfect square trinomial and make it a perfect square trinomial. Let me give you an example. This one is not a perfect square trinomial, but I'm going to show you how you can make it one. So here's our procedure. Step number 1 is to isolate the constant. What this means is I want to write the equation in such a way that the constant, the number that does not have a variable with it, is all by itself. Now in this problem, that's already done. The problem is already done that way, where the constant is isolated because the 9 is all by itself. So that part's done. Second step is to form a perfect square trinomial. Keeping the equation balanced. So I already know what the perfect square trinomial is going to look like here because I just wrote it as x squared plus 8x plus 16. If I were to just put over on the left side of this equation a plus 16, I would have a perfect square trinomial. But the only reason I know that is because I already wrote a perfect square trinomial for you. So if you didn't know how to find that number, the thing that should be added in there, how could I find it? Well, the way that you find the number to be added onto the end, the constant to be added onto the end, we call it C. We're A, B, C in a quadratic. The way we find the value C that needs to be added is we take the B value, which is the coefficient of the X, divide by 2, and square. So B divided by 2 squared. So in this problem, our B value was 8. So if we did 8 divided by 2 squared, 8 divided by 2 is 4, and 4 squared is 16. So that's how I could figure out that it was 16, even if I didn't know it from the previous problem. So I'm going to just, instead of x squared plus 8x, I'm going to do x squared plus 8x plus 16. But look at the second part of this step. Form a perfect square trinomial, done, keeping the equation balanced. I can't just do plus 16 just because that makes the problem easier for me. Yeah, hold on, that's illegal, exactly right. If I just do plus 16, boom, look how much easier it is when I change the problem. Well, yeah, it's much easier when you change the problem. I can't change the problem. I have to keep the equation balanced. So if I add 16 over on the left side, I have to make sure that I balance it out by also adding 16 over on the right side. And that can be simplified. 9 plus 16 is 25. So I'm going to write x squared plus 8x plus 16 equals 25. And that brings us to step 3 in our process here, which is to write the trinomial as a binomial squared. X squared plus 8x plus 16 can be factored, as we already said, into x plus 4 times x plus 4, which is x plus 4 squared. Now, step 4 is we're going to use that square root property that we learned seemingly a month and a half ago. It's been a long time. Use the square root property of equality. The square root property of equality is the whole reason why we did binomial squared in the first place. We had x plus 4 squared, and if I take the square root of x plus 4 squared, what do I get? What's the square root of anything squared? Well, the square root of x plus 4 squared is, waiting for audience participation time. You're just doing 4, not 4, x plus 4. The squared and the square root disappear, and we're left with x plus 4. Now here's the part that's tricky. It's not going to sound like this is tricky. It's going to sound like this is a dumb question, but it's a tricky question, so think about it. What is the square root of 25? Sounds like I'm asking you a stupid question. I promise I'm not. This is a tricky question. What's the square root of 25? I just said like 3 times this is a tricky question. You know the answer is not just 5. I wouldn't say it's a tricky question if the answer was 5. Let me give you a hint. 5 is one of the answers. There we go. Brock got the other one. The square root of 25 could be 5 or negative 5. Square root means what number multiplied by itself gives me 25. 5 times 5 does give me 25, but negative 5 times negative 5 also gives me positive 25. So the answer here is positive or negative 5. This shouldn't really come as a big surprise to us that we're going to have a plus and a minus, because pretty much every other quadratic we've solved has had two answers. This one's also going to have two answers. That brings us to the final step of our process, which is isolate the variable, and we have two equations to solve. Equation number one is going to be x plus 4 equals positive 5. And equation number two is going to be x plus 4 equals negative 5. And we solve both of those to get the two answers. We expect two answers from our quadratic problems. Well, I expect two answers. I don't know what you expect. So, real quick, we'll use the subtraction property of equality. 5 minus 4 is 1, so there's one of our solutions. And we'll do the same thing on the other one, the subtraction property of equality here. X equals negative 9. And so the two answers to this problem are positive 1 and negative 9. Why do we need, because the square root of 25 could also be negative 5. Negative 5 times negative 5 is positive 25. Anytime you take a square root, you end up with two solutions. Are you picking up what I'm laying down? You smell what the rock is cooking? Okay, let's try another one. Okay, step one is to isolate the constant, which we have done. The constant is isolated. Perfect. Step number two is to make it a perfect square trinomial, keeping the equation balanced. So the b in this problem is negative 6. So to figure out the c value, very good, b divided by 2. So negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So we need to add 9 to both sides. So we will have x squared minus 6x equals 7, and we're now going to do plus 9 on both sides. And then what will x squared minus 6x plus 9 factor into? Is that what that smell is? Brain farts? X squared minus 6x plus 9, what will it factor into? What are our two parentheses? Two numbers that will multiply together to be 9, but will add to be -6. Yep, x minus 3 times x minus 3 is exactly right. And we'll go ahead and do 7 plus 9, which is 16. You are so smart. I should take back some of the bad things I've been saying about you behind your back. I'm not gonna, but I definitely should. Yo, let's go. Now what? Square root property. Take the square root of both sides. Taking the square root of the left side is really easy. If you take the square root of something that is squared, the square root and the squared cancel out, and we're left with just x minus 3. But what's the square root of 16? Don't say 4. Don't say just 4. 4 and -4. That's exactly right. So positive and -4. Okay, so now we're actually home free. We're gonna solve our two equations. One of them is going to be x minus 3 equals +4, and the other will be x minus 3 equals -4. These are, of course, going to give me two different answers, but they're solved in the same way, which is adding 3 to both sides. So one of my answers will be 7. And the other answer will be -1. And you could write them separately like that, or you can write them as a set. Dealer's choice. Now, I know what you're thinking. You're thinking, Taylor, this is super, super fun, but you know what would make it even better? You know, it would take this from being super fun to like the best experience of my life. And the answer is yes, I do know. It needs some fractions. What if we threw some fractions in there? That would be great. What are the squiggly things? Curly brackets, curly braces. It's just set notation. It's a way for you to write two numbers as a single value of x, write x one time. You can do x equals 7 and x equals -1 like I did in blue, or you can write them both in set notation. Doesn't matter. If you turn them sideways, they kind of look like birds. And if you don't turn them sideways, it looks like Alfred Hitchcock's profile from Hitchcock Presents. All right, step 1, isolate the constant. Looks like it's done to me. Looks like our constant's already isolated. Do we make all the numbers fractions? You could. I don't recommend it, but you could. If you're like, you know what's even better than one fraction? 3 fractions. I guess that's where you want to go. I probably wouldn't, though. I'd probably stick with our plan, which is find the value of b, 3. Just like that. And then divide by 2 and square it. Turn on my little space heater here. My feet are getting cold. Okay, so I do 3 divided by 2 and square it. If you try to type this into the calculator, it's going to give you a decimal, which is not ideal. I think I'd rather just deal with the fraction. The main reason I'd like to deal with the fraction is because my fraction here has a denominator of 4, And my other side also has a denominator of 4. So dealing with the fractions is going to be pretty simple in this problem. So I will have my x squared plus 3x equals 7/4, and I'm going to add 9/4 onto both sides. Like so. So let's go ahead and factor it. What's it going to factor into? That's really hard to factor something with a fraction. But I'm hoping the last two problems we've done, you have you figured out the pattern for what's going to go in the parentheses. Let's go back up and look at these previous ones. This one, the thing that went in parentheses was -3, which is what -6 divided by 2 was -3. This one, the thing that was in parentheses was 4, which is what 8 divided by 2 was, 4. So when you do b divided by 2, that's telling you the thing that goes in parentheses. So down here, b divided by 2 was 3/2, right there, 3/2. So it's going to be x plus 3/2. Now for the grand prize, can you do 7/4 plus 9/4 and then reduce it? Okay. What's 7/4 plus 9/4 reduced? Can you do it? And you said yes. Okay, technically you answered my question. I should have been more specific. What is the answer? I mean, it's not that I don't take your word for it. It's just that I do not take your word for it. 7/4 plus 9/4 is 16/4. 16/4 reduced is 4. 4/1 is technically correct, but weird. Let's just write 4. If you wrote 4/1, that would be fine. You're just a weirdo. Square root property. So we're going to have x plus 3/2 on one side equals, what's the square root of 4, kids? Don't say 2. To a -2. Cool. So now I'm ready to do my equations. I'm going to do x plus 3/2 equals +2. And I'm going to do x plus 3/2 equals -2. You may want to use a calculator for this part if you're not such a stud with fractions. Or you could just be a real man like Brock and tell me the answer right now. Brock, go! 2 minus 3/2. Brock makes a pretty astounding guess. 3,587,496,850. Oh no, sorry. That was 3,587,496,857,654. Which is close, Brock. It's close, but it turns out 2 minus 3/2 is actually just 1/2. So 3.5 trillion was close, but it's actually a half. If you want to think of it in decimal terms, 3/2 is 1.5. So 2 minus 1.5 is 0.5. -2 minus 3/2 is the same thing as -2 minus 1.5, which is -3.5 or -3.5, or if you want to do improper fractions, which everybody loves, -7/2. Those are all perfectly acceptable answers. I like improper fractions. Definitely prefer fractions to decimals a majority of the time. Okay. Let me give you a really hard one. Let me see if I can really blow your mind here. Okay, so what you're seeing there is that one of the reasons this is tricky is that the first step has not been done for us. The first step was to isolate the constant. Is the constant isolated? No. This +2 right there has not been isolated. So this is the first one I've given you in which step 1 was not already done for you. So first thing we got to do is isolate the 2, which is easy to do, to subtract 2 on both sides. There we go. Now it's isolated. You might also notice that it looks a little weird because the constant in all of our previous problems has been on the right side, and the constant here is on the left side. It's not a big deal. We're going to solve it just like this. It doesn't matter which side it's on as long as it's isolated. But if it really bothers you, you could, if you wanted to, you're like, it's got to look the same every time. You could flip this and do, you just switch what side they're on. I'm not going to do that. I'm going to solve it with the constant on the left side just so you can see what it looks like. But it's not an issue at all if you would prefer to switch it so it looks like the last ones. Okay, there we go. Constant isolated. Next step is going to be to, got to find the value of b, which is -10. So b divided by 2 squared is b divided by 2 is -5. Good. And then when we square it, we get 25. We need both of those numbers. And the -5 is the thing that's going to be in parentheses when we factor. And the 25 is what we're actually going to add to both sides. We've got -2 equals x squared minus 10x. I'm going to go ahead and do plus 25 on both sides. And I think you can see at this step why I told you this problem is going to be a little tricky. Because we're going to do -2 plus 25, which is 23. You know, eventually we're going to take the square root of that. So we're going to have square root of 23 in this problem, which is not a whole number. And that's another reason why this one's a little tricky. Our solution is going to be irrational. We are not going to be able to write a whole number for our solution. That's okay. I like irrationals. I'm married to an irrational. So this is going to be 23, and this side is going to factor into x minus 5, because that was b divided by 2, it's -5. And then we will do our square root property. Hippity hoppity, square root property. Okay. Okay, so that's a really good question. Shelby says that is this going to be a decimal that we're going to turn into a fraction so we can work with fractions? And the answer is no, because an irrational number like the square root of 23 is a decimal that goes on forever and will not make a beautiful fraction. The fraction will be, if you could even turn that into a fraction, would be god awful. So we're just going to leave it as the square root of 23. Leaving it at the square root of 23 offers us a couple of advantages. The big advantage from a mathematical standpoint is that the square root of 23 is the exact answer. We won't have a rounded answer. Our answer is going to be for sure the exact right answer. And the second advantage it offers us is by not taking the square root of 23, by just dealing with that number that has the square root, we avoid all the unpleasantness of really awful decimals or ugly fractions. So I'm just going to leave it as the square root of 23, but even though I'm leaving it as the square root, the same idea applies that taking the square root gives me both a positive and a negative answer. So this is not going to be just the square root of 23. It's going to be positive or negative square root of 23 equals x minus 5. After I do the square root property, I'm ready to do my equations, which is going to be square root 23 equals x minus 5, or negative square root 23 equals x minus 5. And it looks like this is really horrific, but the math here is pretty simple. All we're going to do is add 5 on both sides here. And this is why the math is pretty simple. I cannot add 5 and the square root of 23 to each other. Can't do it. One's a square root and one's not. I can't combine those without turning the square root of 23 into a decimal, which I already said we don't want to do. So we're just going to leave it as the square root of 23. My answer is going to be 5 plus the square root of 23 equals x. That's one of my answers. I'm just going to leave it exactly like that. I'm going to do the same thing over here. I'm going to add 5 to both sides. That's going to be 5 minus the square root of 23 equals x. And that's it. If you really want to impress the ladies at the math party, you can write this as 5 plus or minus the square root of 23. And that is a pretty clever way to write the answer. Instead of writing two answers, you just put a plus minus. Be like the square root of 23, never change. Be irrational and never change. That's terrible advice. Be like the square root of 23, irrational, difficult to work with, not especially good looking, hardly any redeeming characteristics, and never change. Be a stain on the society and never change. Okay. How are we feeling about this? With the exception of, I don't love square roots. How are we feeling about completing the square? This is not the only time we're going to work on this. We're going to do some more completing the square later. Like tomorrow, we'll do some more completing the square. But for now, how do you feel about it? Right, so I'm going to share these notes with the two of you via email so that you'll have these. Shelby, I know you like to keep your digital notes. And Brock, you're just getting added to the email whether you want to or not. If you'll give me just a few moments, I will adjust the notes for Shelby, because Brock, I don't think you need this unit. I think you were just doing it for kicks. But I'll go ahead and adjust it for you, Shelby. Brock, you need to get the square root property done. Same for you, Shelby. You guys are both, or Shelby, you're on the zero product property. Brock, you're on the square root property. You'll need to get that done rapidly, please. so that you're caught up. And I'm going to be adjusting your due dates for assignments for the rest of the day today to make up for the week that we missed. So it's going to take me just an incredibly long time to do it. And your progress bars on Edgenuity are going to be going bananas while I'm doing it. So don't freak out, but I'm going to be adjusting some things so that you can not be miles behind because of the snowpocalypse. Okay, I'll be in Zoom for the rest of the day. So if you want to hop in and ask a question on Zoom, you can. And if you prefer to do email or Google Chat, that's fine too. Okay. See you later.